Okay, so now we want to talk about where do you find volcanoes and other extrusive igneous activity. So where is it going to be going on? So here's our model of plate tectonics, and we found out that plates can be pulled apart, plates can be pushed together, and then plates can slide past each other. So let's explore these various kinds of environments. So the first one that we want to talk about is going to be where the plates are being pulled apart. Now there were two different places where the plates could be pulled apart. So plates could be pulled apart where you have an ocean and an ocean, and then that made a mid-ocean ridge, or you could have a continent being split, and so that's going to make a crack, and then eventually if they are pulled far enough apart, the crack starts to fill with water, then you have a lake, and then if it pulls further apart, then you end up with a sea, and then you can finally end up with an ocean in between those two continents. Okay, so let's go back to an ocean pulling apart from an ocean. What would you get? Okay, you're going to be having mafic material from the asthenosphere coming up to the surface. So what kind of volcanoes does mafic material make? Okay, it's going to make stuff that is not very viscous, so it's going to be very runny. So you're going to be expecting to get your shield volcanoes, and you're going to be expecting to get mafic kinds of rocks like basalt. Now, what about on a continent? Well, this is going to be different on the continent because the material that's going to be coming up, which starts out being mafic, is going to be passing through felsic material because the continents are composed of granite. So that means that this mafic material could make it all the way up to the surface without interacting with the felsic rocks, and then it would erupt as a shield volcano, and it would be a basaltic lava, or this magma from the asthenosphere, the mafic magma, could interact with the granitic rocks, and it could alter those, and it could start to become an andesitic, or it could become more of a felsic, which means that you could have a more explosive stratovolcano as a result of this. Okay, what about where the plates collide? Okay, so there were multiple ways that the plates could collide. So you could have a continent colliding with a continent, and then you push up your mountains. You could have an ocean colliding with an ocean, and then one of the ocean plates will go underneath the other ocean plate. Or then you could have an ocean colliding with a continent, and then it goes underneath. So let's discuss these three. So with the continent hitting a continent, you're really not going to have any volcanoes, because once you start pushing the two plates together, there's no way for this material down here to make its way up to the surface to make volcanoes. So normally the continental collisions do not make any volcanoes. Now they do, however, make some intrusive igneous features, but not extrusive. Okay, so let's go with the ocean colliding with the ocean. So each of the two ocean plates are mafic in their composition. They're made of basalt. So that when they collide and one of the plates goes underneath the other one, and it starts to melt, and the lighter materials come up to the surface, well, you're going to end up with, again, a pretty mafic volcano, which is going to be a shield volcano, and it's going to erupt pretty gently. And so you're going to have mafic lavas like basalt. However, what can happen is over time, as this material comes to the surface, it can start to alter the mafic island that it's creating, and it starts to become more felsic. So that eventually these island arcs can start to have more continental compositions. And so we think that this is really the origin of the continents. This is where the continents come from in the first place. So that they start out as these island arc things, and then as they become more felsic, they get larger and larger, and then as they run into other island arcs, they weld together because they can't be subducted because they're composed of less dense materials, and they become micro-continents like Cuba, and then eventually they become larger and larger continents. Okay, now let's talk about what happens when an ocean collides with a continent. So the continent pretty much stays horizontal. The ocean plate is going to go underneath it because it's more dense. It's going to start to melt, and parts of it is going to come back up to the surface. And then this time we're going to have continental volcanism. These are going to be your stratovolcanoes, and these are going to be andesitic. So they're going to be a combination of felsic and mafic. So when you mix the mafic ocean with the felsic continent, then you get the intermediate kind of rocks like andesite, and then you get, again, these very, very explosive stratovolcanoes because they contain a lot of gas. Okay, a third place, so we mentioned divergence and convergence. Another place where you could have volcanism is at these hot spots. So in the middle of a plate, you can have a hot spot where material is coming up and making volcanoes. Well, it could be in the middle of an ocean plate, in which case you're going to have mafic material coming up, and it's going to produce the shield volcanoes, and it's going to be the very gentle eruptions of basalt. Or you could have the hot spot underneath the continent, in which case the material could come up unaffected by the felsic rocks of the continent, and then it erupts as a shield volcano and it's basaltic. Or it could interact with the felsic rocks, and then you could have a stratovolcano, and then you could have more felsic and intermediate rocks that explode out of those volcanoes. Well, there's one more, and that would be transform. So what's going to happen at the transform boundary? Well, not much. So it's not really an area that is going to be known for volcanoes, but I guess you could have some igneous intrusions inside the Earth, but it's not really going to be making it to the surface. Now, all of this is summarized on this chart here. So if you want to pause me so that you can read this. So this talks about what kind of boundaries do you have. Is it divergent, or is it convergent, or is it transform, or is it hotspot type activity, interplate activity? And then it tells you where would you find some of these kinds of interactions, and then it shows you what kinds of rocks would be produced, and then what kinds of features would be produced at the surface. All right, so let's take a break, and when we come back, let's talk about why are volcanoes so dangerous.